Okay, imagine for a second that you're a scout for an NFL franchise. You're an analyst, and they hand you a formula and say, this is how we're going to rank and give scores to all the different players that we're scouting. And it's 3x plus 2y minus w plus 5x, where x is vertical jump in inches, y is bench press reps, and w is pounds for that particular player to be overweight. And we're going to use that to create an overall combine score to be used to rank players in the upcoming draft. But what does it mean? How do you simplify it? So today we're going to go ahead and find out. Welcome to Phorge Mathematics. I'm Ryan, and today we're covering two skills that show up everywhere in algebra: evaluating expressions and combining like terms. These are tools that turn messy math into clean answers. So let's go ahead and hop into it. Let's go over the learning objectives for today. By the end of this video, you will be able to identify parts of an algebraic expression, the terms, coefficients, variables, and constants. Then you'll be able to evaluate the expressions by substituting values in for the variables. You'll be able to identify and group like terms and combine like terms in order to simplify. So let's move on to part one. So part one, the anatomy of an expression. So the term is a single piece, a number or variable, or both multiplied together. So this right here would be a term. Next would be the coefficient. So in this case, it would be this 5 would be the coefficient. And then a variable, so like the placeholder x, so in this case, x would be a variable. Then constant, so in this case it would be this lone number, would be the constant. And then an exponent. So in this case, the only exponent we have is this 2 and the x squared, which would make this an exponent. Okay. So think about this as like a fitness tracker formula. So calories is equal to 8m plus 5s minus 2r, where each term has a job. M is the minutes spent running, S is the sets you've spent lifting, and R is rest minutes. You need to know what each part means before you can use it. So let's move on to part two. Evaluating expressions. So evaluating is substituting a number for each variable and then computing out using PEMDAS. So first, you want to write out the expression. So in this case, our expression is 4x minus 3. So we're going to write 4, and then I'm going to leave a parentheses like that. It's going to be blank, and I'll show you why. And then we're going to substitute in with the parentheses, so in this case, 5. And then now we just follow PEMDAS. So first, what's the first thing that we need to look at? Do we see any parentheses? Yes, we see some right here. 4 times 5 is 20. Okay. Do we see any exponents? Not in this expression. Do we see any multiplication / division? Nope, not in this problem. And then do we see any addition or subtraction? Yes. 20 minus 3 is 17, and that'll be your final answer. Okay, let's move on to part 3, combining like terms. So which of these is like terms? So let's start with 3x. So we'll write 3x minus 2x. Do we see any just regular x? No, we do not. Then we have 7x squared and 2x squared. And then we have just constants, 5 and negative 8. So if we were to combine these, we would just do what the signs say. So in this case, the first one would be 2x
3x minus 2x is equal to just x. 7x squared plus 2x squared. So in this case, we only want to work and add the coefficients. So 7x plus 2x is equal to 9x squared. And 5 minus 8 is equal to negative 3. So you need to be very careful that you're adding similar terms. So you can't do negative 8 minus 2x squared and say that it's negative 6x squared. That's just not going to work. So what you need to do is you need to make sure that the variables match up, and then you can add those coefficients. So let's do some practice problems of combining like terms. So you add or subtract the coefficients like we were saying and keep the variable tag identical. So in this first one, 5x plus 3x can be simplified down to 8x. 6x squared minus 2x squared can be simplified down to 4x squared. Can we combine 5x and 3y? No. So the simplest that you can keep it is at 5x plus 3y. We can't simplify it any further. Okay. Let's move down to some worked examples. So in this case, we have 2x plus 3y. So let's say x is the distance that you spent running, or the minutes you spent running, and y is the minutes you spent lifting weights. So in this case, the formula is 2, empty parentheses, plus 3, empty parentheses. So we need to make sure that we put in the right terms where they're supposed to go. So in this case, 2x, x is equal to 4. So we put 4 where x would be, y is equal to 2, 3y, we put 2 where y would be. So now we just use PEMDAS to go ahead and solve this. So what I like to do is, if I'm ever doing PEMDAS, I like to write it off to the side. And don't be afraid to write this off to the side to keep you keyed in on what the next step is. So do we have any parentheses? Yes, we have 2 sets. So 2 times 4, that is going to be, this is really a multiplication, so we'll do multiplication. Is there anything we can do to simplify the parentheses? No, not really. Is there any exponents? No exponents. Is there any multiplication / division? Yes, there's 2 sets of multiplication. So 2 times 4 is equal to 8. Jumped ahead a little bit. And then 3 times 2 is equal to 6. So now, the only thing we have left is addition / subtraction, and 8 plus 16 is equal to 14. Okay, let's see if we can go ahead and try and simplify 7a plus 3b minus 2a plus 5b. Let's start with this first one here. So we have 7a. Are there any other variables that have a? Yes, right here, minus 2a. 7a minus 2a is equal to 5a. And one thing I like to do is just cross out those so I know that I don't try and double count those later on. So now the next one is 3b and 5b. 3b plus 5b is just equal to 8b. So our final answer is going to be 5a plus 5b. We can't simplify it any further because a and b are not the same term. Okay, so now let's try and evaluate. Evaluate means we're going to have x equals to something. We know that we're going to have to plug this in to this expression. So we have 3. Everywhere you see an x, go ahead and put that in. The x is equal to 3. Okay, now what we need to do is we just need to do PEMDAS. So write PEMDAS off to the side. Do you see any parentheses? Yes. We do see some parentheses. However, it's really just parentheses / exponents, just based off the way I wrote it. So we're going to be evaluating these two steps at the same time because they're kind of the same right here. So 3 squared is equal to 9. 3 times 9 minus, can we simplify that parentheses anymore? No, we can't. So we can do 2 times 3, which is the same as doing that. Next is multiplication. 3 times 9 is equal to 27. We'll keep the subtraction. 2 times 3 is 6. And plus 1, because we're not worried about addition or subtraction right now. So now we can just go from left to right, adding and subtracting. So 27 minus 6 is equal to 21, plus 1 is equal to 22. Okay, let's go into look at the example number 4. So be careful, this is going to be a trap. And what we're going to do is we're going to simplify. We have 4x plus 3x squared minus 2x plus x squared. So what I like to do is I like to underline the terms that are the same. So in this case, 4x minus 2x, the x is equal to each other. X squared is not the same. So we have 4x minus 2x. It's just equal to 2x. And then I like to cross out the term so that I know that I don't double count it later. Same with that negative 2 there. So now let's move on to the x squared. So we have 3x squared and positive x squared. So what's 3x squared plus x squared? This is 4x squared. And so and then when we do that, that's going to be our final answer right here. So let's move on to some common mistakes. Okay, let's go over some common mistakes. Combining unlike terms. So 5x plus 3x squared is not going to equal 3x cubed. The key here is the exponents. If you have different exponents, you cannot combine those type of variables, even though the base of that may be the same. Skipping parentheses on substitution. This may cause sign errors. So make sure that you don't skip parentheses if you see some. Adding exponents when combined. So just because you add the coefficients, I mean you also add the exponents when you combine them. And do not drop negative signs mid-problem. And also, do not treat x and x squared as the same term. They are always different. Okay, let's go to some additional problems. Go ahead and take a couple minutes, pause this video, and see if you can solve these problems, and then put it in the description or in the comments how many you got right. Okay. And here are the answers to those problems. Make sure you take your time, see if you got them right.
Okay, let's do a quick recap of what we learned. So we learned how to evaluate substituting in a variable that we know the value of. So like x equals 2, we plug in 2 everywhere we see x, and then we use PEMDAS to evaluate that expression until we get it all the way down to a single number, or to all the variables that we don't know. So like terms, it's the same variable and same exponent. The key is the same exponent. We combine like terms, we add and subtract coefficients. We don't add exponents of the variables, and the variable stays identical as long as it's the same. So if you got all 5 practice problems first time go, you're ahead of the curve. Go ahead, put comment down that you got all 5. Hit like if this clicked for you. Subscribe so you don't miss the next one. So drop any questions you have in the comments, or you can email me at phorgemath@gmail.com. I read every email, I read every comment. And so I can't wait to see you at the next video where we continue working through more algebra. Have a good one.